In this video, you will find out how to make Among Us in Unity. I'm Adrian and welcome to Redefine Gamedev, a channel focused on finding success in game development. If you're interested in this, then what are you waiting for? Smash that subscribe button. We will cover a lot of game development related topics today, so if you feel overwhelmed, you can check my previous video regarding how to start game development in Unity, which should be popping up right now. If you are not overwhelmed and you want to get straight to the point, let's move on. This video has the following structure. First, we'll discuss about tools and what you need to start working on a game today. Then we'll move to how to create art, of course, programmer art in this case, and then we'll see about the gameplay, implementation, and lastly about how to create the multiplayer. Okay, moving on to tools. Since you want to get started ASAP, I'll recommend mostly free tools, so you can start today. The game will be built upon Unity, which is a free game engine that is one of the most popular ones out there, so you can grab it right now on their webpage. The art assets will be created in Inkscape. Of course, you can create them in GIMP if you want, or in Paint if that suits you better. It's no problem. And lastly, we will use for multiplayer Photon Cloud, which is a free service up to 20 connections, and of course you have to pay after, but for the purpose of this video, it's no problem. So for the art assets, let's dive into Inkscape and let's get started. I will start by creating the character. This is done mostly by using a reference picture found online. It's much easier to do 2D and 3D art by using references. To map the general shape, I use a tool called Draw Bezier, but any line tool would be just fine. Of course, I am putting my own spin to the art. I will also create two different characters with different colors, though we will see just in a bit later that the idea was scrapped for something even better. Now let's head over to Unity and see how we can import the assets that you created and how we can create the simple logic. After downloading and installing Unity, you will be prompted with this project creation screen. From here, I chose Universal Render Pipeline template and gave the project its name. I copy-pasted the PNG files from Inkscape to the project's files. This is how they ended up in the project view. To be able to use them, we need to change their texture type to sprite. And of course, don't forget to hit apply. And now, if we create an empty game object with a sprite renderer component, alternatively you can create it from the drop-down top menu, we can fill the field with the sprite with the imported image. And now, I figured out that the sprite renderer has a parameter that can specify the tint of a sprite. We can use this to have as many colors as possible to the characters. The only change required is that the object needs to be split into fill and outline, because we will only change the color of the fill. Now, to have a proper character, I will create an empty game object which will be parent to both the fill and the outline of the character. I will also add a box collider to the parent game object. This will allow us to detect collisions between the player and the environment. I am also preparing the character for movement. This is done by creating a move script and attaching it to the player via drag and drop. As I run the game, I notice that the eyes of the character get rendered behind the fill. In order to fix this, we need to change the order of the drawing. Now let's get started with the movement script. There are mainly two ways to move objects in Unity. The first one is by directly changing the object's position, which is kind of intuitive. And the second one is for the objects that interact with physically based environments, and we need to change the rigid body instead. We will use the rigid body movement in this one. So for this I created a rigid body container, which is called RB. In the awake function we get that component. We also will use velocity, which I'm set to 0. To actually move an object, we need two steps. First is input gathering, and for this we use the update sequence. The update is a function that it's called every single frame. We store that result in the velocity. In the fixed update, we actually move the rigid body. This is done with a function called move position. As parameters, you use the current position, which gets added also a mix of velocity, which is the new directional vector, the speed, and the delta time. The delta time assures that no matter how fast the game is rendered, let's say 60 FPS or 120 FPS, the actual movement of the object will be the same. You can see this in older games. If you put them on new PCs, they might move faster because the programmers didn't implement this. And this is the final result. We can see that the character is moving. Now let's get the environment done. For this, I have created two more objects, ship floor and ship wall, and imported them into Unity. I've decided to make the player, the wall and the floor prefabs. Think of prefabs as blueprints, which can be created multiple times in the scene. The main advantage of a prefab is that once you change the blueprint, all the objects in the scene using that prefab will automatically change as well. To create the prefabs, we simply have to drag and drop the objects from the hierarchy to the project. They will turn blue as they change to a state from simple objects to prefabs. Each prefab can be edited individually into a separate place. This is done by clicking on the small right arrow. As you can see, the player can go through the wall. So at this point we need to set up the rigid bodies to finalize the collision. We need to add rigid bodies to the wall and to the player. For the player we will use the dynamic one, with the gravity set to 0 and freeze rotation active. Note that if we change the prefab in the scene, the actual components will be highlighted with a blue line in their left side. To make sure that all the prefabs of the same type get these changes, we need to override them by going into the override menu and hitting apply. And now the collision should work properly. By the way, if you are implementing by this tutorial, just at this point you will achieve player movement because of not adding rigid body before. And now I'll start creating the environment. I'll speed up this process since it's mostly copy-paste. As for the camera, we can change its projection to orthographic since it's a 2D game. By changing the size, we actually zoom in or out of the action. Also, while here, I'll remove the skybox and replace it with a solid color and a dark background to simulate space. As you can see, the camera still doesn't follow the player yet. So let's create the camera movement script and get going with the code. First, we will create a transform property that will be the camera's target. The smooth time property is the smoothness factor in the movement. In the update function, we calculate the new position by getting the target's position from the local space to the workspace. Then we adjust the current position with the smooth depth functionality. This takes 4 parameters: the current position, the target one, the velocity, which needs to be a reference variable, and the smooth time parameter to give the desired smoothness. Let's add the player to the camera with drag and drop and test it. Now that we have everything set in place, we can look into multiplayer and see how that goes into the project. For the multiplayer, as mentioned before, we will be using Photon Cloud. If you are using Unity 2020, then you need to use the package manager to import Photon into your project. Make sure that you have selected packages, My Assets, and search for Photon. If this does not appear for you, you first need to go to the SS Store webpage, log in with your account and add Photon Network Unity 2 to your packages and then come back here. You first need to download the package, then import it into your project. Now we need an app ID. To get this, you need to head over to Photon webpage, create an account and then go to the dashboard. From here you can create a new application, give it what name you want, and then from there you can get its app ID. You take that app ID and input it into Unity's settings for Photon Cloud, which should automatically appear. Also note that Photon offers extensive documentation on their website. Let's now create a network script and get right into it. Of course, for a script to actually get executed in Unity, we need to first attach it to object in the scene. I created an empty game object called network and attached the script as a component with drag and drop. For debugging purposes, I created a simple 2D text which I'll be using to display the current connection state. If you want to use this, you can create yourself. Alternatively, you can use debug log to output it in the console. Let's head over to the network script. In the start function, we will display the state and generate a unique name for the player. Then we will attempt to connect to the Photon Cloud. Now, most of the functionalities will be created via callbacks. Callbacks are functions called when an event happens. For example, the connection was successful. To enable Photon callbacks, we need to extend the mono behavior upon callbacks. But connected to master only means that we are in the server. We need to join the room as well. For this functionality, we will use join or create room. There are a couple of parameters needed here, but the most important are the name of the room and the number of the players accepted. Lastly, we will also add the onJoinRoom callback. To make the player's actions visible on the network, we need to add more components to the player prefab, one of them being the Photon view, which allows the Photon components to sync. The other one is the transform view, which allows the position to be synchronized on more instances. Also, don't forget to override the changes if you edit the prefab in the scene. We need to prepare the scene a little, so I will move the scene to have its coordinates in 0, 0 and check the player's position relative to it. This will be used when instancing the player from the code. And speaking from instantiating from the code, we will remove the player from the scene. In order for Photon to instantiate networked prefabs, we need to create a folder called resources and move the player prefab in that folder. It doesn't matter where the resources folder is though. As for the code, we go back to the network script and instantiate the player when the player gets connected to the room. Note that the position is randomized between the values that we checked before. And now let's put it to the test. One thing to note here, since we remove the player from the scene, the camera is no longer attached to the player, so we need to fix that. We will add a camera reference to the network script and then set the target of the camera when the player gets instantiated. And now the camera should work as well. One last note here, Since the camera doesn't have the target from the beginning, we need to perform a null check in order for us to have the console clear of errors. Now we can actually test the multiplayer. We need to create a build, and after the build, if you run the build and you run the game, we end up having two players in the same scene. But you might see a small problem that the one player can move both of them, so we also need to fix that. The fix lies in actually testing in the move script if the player belongs to us, and we can check this by checking the owner of the photon view. Of course, to enable photon view to work, we have to extend the photon pun mono behavior, and then we will be able to query the photon view to see if it's the owner or not. One last thing as a bonus here, would be nice if we can actually have multiple colors to the player. We can do this by going to the player prefab, create a new script and attach it to it. And then we will see how to synchronize the colors between multiple instances in the network. By creating the player info script and extending the IPON observable, we now have access to the onPhoton serialized view. In here we can synchronize data between the clients. If the stream is writing, that means that we are the owner, so we can send the color over the network, and this is an integer, which means a number. And if not, if you're not writing, then it means that we are another player, so we just have to decode that value and then use the color index to put it in the other instance to see the correct player's color. Here I also added a list of predefined colors, which we will define shortly. One thing to note here, if we add the initial colors, they will be alpha 0 for some reason, so you won't see any color. So we need to go back and change the alpha for each and every color. So this is the final result with multiple players having multiple colors. One last thing to mention here, I encountered some problems connecting to the same room, so instead of opting for creating random room name, I set the name to game room for all the rooms. After this point, it's game on basically. If you're interested in the second part of this video, please leave a comment in the comment section down below, because I'm really interested of your feedback. Game development is fun. It's actually one of the most interesting things you can do in this world. But the development part is just one small part of the whole thing. If you want to find out what are the other ingredients for success, you are in luck, because this channel offers exactly that. We will look here at what else you need in order to have success in game development. So consider subscribing because more videos will follow. I'm Adrian and I'm signing out.